Hello, I'm on page 27 in your note packet, ratios involving sides, perimeter, area, and volume. We're going to begin with two squares which have side lengths of 2 and 3, so let's go ahead and draw those. What do we know about the sides of a square? They're all the same, so they're all 2. And the angles are all 90 degrees. The other one is just a little bit bigger, having side lengths of 3. And again, the angles are all 90 degrees. So are those two squares similar? And if so, why are they similar? Well, one of the characteristics of being similar is that all corresponding angles are congruent. And in this case, because all right angles are congruent, we have actually all the angles being congruent. And then the ratio of the sides is going to be 2 to 3 from each side of a smaller square to the larger one. So explain why the squares must be similar, because all angles are congruent and all sides are proportional. All sides are proportional. And we could even say with a scale factor of 2 to 3 if we're going from smaller to larger. So we're going to go from smaller to larger for the rest of this problem. And it says for part B, what is the ratio of the corresponding sides? Again, that we just figured that out. That's 2 to 3. Part C, what's the ratio of their perimeters? Pause the video and find the perimeters of each of those squares, please. If I add up all the sides of the smaller square, I get 8. If I add up all the sides of the larger square, I get 12. So 8 to 12. How does this compare to the ratio of the sides? Well, what number goes into both 8 and 12? If I divide 8 by 4, I get 2. And if I divide 12 by 4, I get 3. And when I simplify, what do you notice? Oh, it's the same as the ratio of the corresponding sides. So the ratio of the perimeter ends up being the same as the ratio of the corresponding sides. Now part D, what's the ratio of their areas? Go ahead and find the areas of each of those squares, pausing the video. And if you forgot the formula, it's length times width. So the smaller square, length times width, would be 2 times 2, which is 4. And the larger square would be 3 times 3, which is 9. So the ratio of the area, smaller to larger, is 4 to 9. How is this going to compare to the ratio of the sides? Well, look at this. What's another way to write 2 times 2? And another way to write 3 times 3? I can write 2 times 2 as 2 squared. And 3 times 3 as 3 squared. And how does that relate? We took the ratio of the corresponding sides and we just squared the 2 and squared the 3. So we squared them. When you're given a unit of something and you're asked to find the area and we label the units like centimeters squared, that means you have the area. So think area unit squared. The last part asks, 2 cubes are built using the squares as faces. What's the ratio of the volumes of the cubes? Remember, volume formula for a cube is length times width times height. So go ahead and pause the video and find those volumes and the ratio there. So for the smaller one, 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And for the larger one, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So in this case, the ratio of the volumes is 3 to 27. I'm sorry, 8 to 27. Okay, now again, how is this going to compare to the ratio of the sides? Well, 2 times 2 times 2 can also be written as 2 cubed. And 3 times 3 times 3 can also be written as 3 cubed. So how is that going to relate to the ratio of the sides, which was 2 to 3? We took the ratio of the sides and we cubed them. If you think about units for volume, it's always units cubed. So take the corresponding sides ratio and cube it to get the ratio of the volumes. So now for any two similar figures, to find the ratio of the perimeters, that's just going to be the same as the ratio of the sides. The ratio of the perimeters is the same as the ratio of the sides. So if you know one, you know the other. Number 2, explain how you would find the ratio of the areas. You take the ratio of the sides and you square it. And you would square both numbers in that ratio. And then explain how you would determine the ratio of their volumes. You would take the ratio of the sides and cube it. And this part, the bottom part, you're going to want to remember this. Put a little star next to that. And then you are ready to try the practice on the next page. Thanks for watching.